So, hello guys, this is Dr. Edwards again. So, in getting ready for the second examination, let me give you some suggested solution for this study guide. And if I were you, I would spend a lot of time on this study guide before the examination takes place, as well as your homework that you've been doing in the class. Question number one, why are structural formulas more important in organic chemistry than in inorganic chemistry? The reason is that in organic chemistry, there are so many more isomers, isomers, so many more isomers in organic chemistry than in inorganic. And with the structural formulas, you can see the connection between the atoms. And since the connections differ depending on isomers, you have different properties. Therefore, it's good to be able to see the connection between the atoms in the formula. And that's why we need more structural formulas than in organic chemistry than inorganic chemistry. Both for all isomers, they have the same molecular formula, but their structural formulas depend on the shape of the molecule, and therefore they will be different, having different properties. Number two, the isomers of a compound have the same chemical formula. In what ways do they differ from one another? I just stated that. Isomers then of a type have the same molecular formula, but they differ in structural formula. And since the structural formula is different, the properties of isomers would differ also. Number three, how many electrons are shared in a triple bond between two carbon atoms? For all single bonds, there are 2 electrons shared. For double bonds, there are 4 electrons shared. And for triple bond, there are 6, always kind of dispairing. So 1, 2, 3. So there are 6 electrons are shared between 2 carbon atoms for triple bonds. Number 4. What role does air play in combustion? Absolutely, air provides the necessary oxygen that's used in all combustion. You cannot have combustion taking place without the presence of oxygen. Therefore, you must have it. Hold on for a moment. Number five. For a given amount of energy to be used for its propulsion, a spacecraft must have larger tanks than an airplane. Why? As we stated, the spacecraft must carry its own oxidizer. And if that's going to be oxygen, so the spacecraft must carry its fuel and the oxygen that it needs as an oxidizer. Where an airplane that stays in the atmosphere can extract oxygen directly from the atmosphere for its combustion processes. Number 6, what is the origin of energy liberated in an exothermic reaction? So exothermic reaction gives off energy. It must be the arrangement of potential energy between the particles of the molecules, and that arrangement will change during the exothermic reaction, liberating energy in the form of heat. So its potential energy is the origin of exothermic of energy liberated in the exothermic reaction. Number 7, why are there more carbon compounds than compounds of any other element? Carbon sits in the unique place in the periodic table. It has 6 electrons in its in its outer shell, but 4 in the outer subshell. So there are only 4 electrons that will bond in a chemical process. And therefore, carbon has the tremendous ability to bond with other carbon atoms. So each carbon atom has the ability to bond readily with other carbon atoms, where other atoms do not have that same tendency. Silicon will to some extent, but which sits right under carbon in the periodic table. But only carbon then has this unique ability that one carbon atom will bond with a next carbon atom and a next carbon atom, etc., etc. So you can have long chains or many cycles then of carbon compound. Number 8. In what ways do organic compound as a class differ from inorganic compound? The simple answer is that organic compounds must contain the carbon atom. Okay, I'll leave it right there. Number 8, 9. What is the principal bonding mechanism in organic compound? The principal bonding mechanism in organic compound is the covalent bond. C-O-V-A-L-E-N-T. The covalent bond is the principal bonding mechanism in all organic molecules. Is gasoline a compound? If not, what is it? Gasoline is not a compound. It is a mixture of alkanes, A-L-K-A-N-E-S, alkanes. And so, therefore, it's a mixture of those. Now, let's go to a few of the multiple choice questions. I really like the exercise question, but I have some of both on the test. When something burns, what happens when something burns? Does it combine with phlogiston? No. It gives off phlogiston? No. It combines with oxygen. It does not give off oxygen. When something burns, it combines with oxygen. Number 2, substances of unknown composition is heated in an open container, since it's open to the atmosphere, and it's neither A, B, or C, it's D. Any of these, depending on the nature of the substance and the temperature reached in terms of the mass that may be available at the end of the process. Number 3, chemical energy is stored within atoms, molecules, and ions. In what way? It is this electron potential energy. We mentioned this term before. In exothermic reaction, it is the electron potential energy that releases that energy. Therefore, chemical energy is stored as electron potential energy. Number 4, when a catalyst promotes a chemical reaction, it usually does so by doing what? Providing energy? No. Providing electrons? No. Providing activated molecules. That's the difference. It generates these activated molecules, and that's what gets the process started and help to keep it going as well. Number 5, the speeds of reaction between ions in solution. The critical phrase here, between ions in solution, depend critically upon temperature, or essentially independent of temperature, depends upon which catalyst is used, or slow in general. Essentially independent of temperature, number 5. Number 6, at equilibrium, both the forward and reverse reaction has ceased. That's no. The forward and reverse reaction are proceeding at the same rate. The answer is B. Number 7, a catalyst activates which one or more of the following? The energy needed for a chemical reaction to occur, the energy a chemical gives off, the speed of a chemical reaction, whether a substance is oxidized or reduced. A catalyst affects the speed of the reaction. A number of formula units in a mole of a substance is the same for all substance. 8 is D. Number 9, the science of organic chemistry has as its subject, which one here? Carbon compounds. B. It's not A, compounds made by plants and animals. No, it's not C, and it's not D. Number 10, compounds with inorganic compounds are in general most organic compounds, let's see, compared with inorganic compounds in general. Most organic compounds are more readily soluble in water, are more easily decomposed by heat, reacts more rapidly, I think are more easily decomposed by heat. Number 11, the number of covalent bonds each carbon atom has in organic compound. It can have 1, 2, the number of covalent bonds each carbon atom has. It can have 1, 2, it can have 4. Each carbon atom has 4 covalent bonds. So the answer here is C. 12, the number of covalent bonds possible now. That's different than the question we just asked. The number of covalent bonds possible between 2 carbon atoms in organic compound. 1, is it 1 or 2? Is it 1, 2, or 3? The answer is 1, 2, or 3. You may have a single bond, double bond, and triple bond. So therefore you can have up to 3. 13, as a class, the alkanes are highly reacted, soluble in water, unaffected by acids and bases. The best answer is C, acids and bases. 14, in general, alkane series of hydrocarbon, a high molecular mass implies a high boiling point. Okay, so that's the answer there is B, high boiling point. Gasoline is a mixture of alkanes. A. 16, compounds that have the same molecular formula but different structural formula are called isomers, ISOMERS. 17, unsaturated hydrocarbon molecules are characterized by double or triple bond between the carbon atoms so that additional atoms can be added readily. 17 is A. 18, the number of bonds between carbon atoms in acetylene. This is C2H2. This is the simplest one of the alkynes. And so there are 3 bonds there in that particular molecule. 19, which of the following compounds can exist? Only the ones with an even number of hydrogens here. So C2H4 is the only one that can exist. A chemical reaction that absorbs energy now is an endothermic reaction. Complete the following table by giving the name of the alkane and when it is missing, or the formula when it is missing. So the first one is methane, CH4. The second one is ethane. The third is propane. The next one is C4H10, which is butane. C5H12, which is pentane. They all are based on this formula. C sub N, H sub 2N plus 2. So if you know the N for carbon, the number of carbon, you can easily calculate the number of corresponding hydrogens. So to continue, so here then, the C sub 5, H sub 12 for pentane, C sub 6, 8, 14 for hexane, and the next one is heptane, C7, H 16, octane for your half here. That's all.